Reimer-Tiemann reactions. In this class, we will extend the discussion towards bit deeper. So let's perform the Reimer-Tiemann reactions in presence of CCl4 and KOH. So obviously here the phenoxide ion will be formed. Now you see this is the carbon tetrachloride molecules. Here there is no formation of dichlorocarbon intermediate. So you see the resonating structure here. This will attack here and here. Cl is the good leaving group and depart. So the structure will be okay. Now the base will again abstract this proton and it will form now due to the presence of water molecules or base here, all the three chlorines atom will be substituted with the OH, and now there will be the release of the water molecule forming the carboxylic acids. Now this is base and this is acid, so it will react, that means this proton will be abstracted and it will form the potassium salt or sodium salt of carboxylic acid according to the presence of the base. Okay, so this is the final product. If we will case we are taking carbon tetrachloride in place of chloroforms. Okay, so now we'll take some interesting cases, for instance pyrrole. So in presence of chloroform and base, what will forms? So as base is present, it will take this proton. So now the negative charge is appearing here. Now what will happen? Here we know the intermediate is dichlorocarbon. Here the intermediate is dichlorocarbon. Now what are the conditions are coming here? Suppose it is electron deficient and it is electron enriched. So in one case someone might think like that, this dichlorocarbon, it will attack here and the product may form like this. Positive, negative. But what happens in this case? There is no chance of formation of or gaining of aromaticity. But if we will case the other scenario, if we will think about the other scenario, what will happen? You see, now this is the dichlorocarbon and it is a singlet dichlorocarbon. Here vacant. This orbital is vacant and this orbital is occupied with a lone pair. So what will happen? So this lone pair will attack here and this pi bond will attack here, and some kind of cyclic structure is formed. Okay, what is the advantage of formation of this structure? Because after the formation of this structure, it will moves towards the forward reaction, because if we will perform the resonance here, it will form an aromatic ring. Okay, chloropyridine 1 2 1 2 1 2. So 2 chloropyridine is pyridine is formed. This structure is more and more stable than this structure. So obviously here the product is 2 chloropyridine. Okay. So one more interesting facts come out of these discussions. Suppose in place of uh, chloroforms, using if I am using dichloromethanes, let's see what may be the scenario. Dichloromethane CH2Cl2KOH. Okay, so obviously the step 1 will be the formation of this anion. Now here the formation of dichlorocarbon is the intermediate, but here the intermediate will be CHCl. So now the cyclic structure will be HCl lone pair. Now it undergo resonance, and this chlorine departs as the good leaving groups, and the formation of pyridine molecule takes place. Okay, so when we are taking chloroforms, we are end up with the 2 chloropyridine, but when we are taking pyrrole, we are end up with the pyridine. This is the some interesting result of this Reimer-Tiemann reactions. Now let's take another molecule, for instance indole. For instance, we are taking one indole molecule. Okay, and we are taking the ideal Reimer-Tiemann reactions conditions. So as expected, this OH minus will abstract this proton. Now what will happen? We will see. Okay, now from these three types of cases will arise. The point is that here the intermediate is dichlorocarbon. So if directly this lone pair attacks here, then the product will be, this is not at all favorable. Okay, what will be the other product? Suppose this is the, and our intermediate is dichlorocarbon. So one kind of resonance may takes place here, and the product form is here positive charge and one proton is present, obviously the base will abstract this proton and there is a regain of its normal structure, and due to two times of substitutions of OH minus, now we will get this product. With the release of one water molecule. So here formation of aldehyde takes place in the indole molecule. So this is one probability and this is other probability, and the third one we'll see. The third probability is that now this is the lone pair, like the previous case in the case of pyrrole discussions. Here this is the dichlorocarbene. One is vacant orbitals, other orbital is occupied with lone pair. So what will happen? It will undergo a type of cyclization and it will form now you see the resonance carefully. This electron pair will go there and this will go there and Cl minus will depart as it's a good leaving group. Okay, so it will form 1 2 3 4 5 6 membered ring, and chlorine position is this is nitrogen 1 2 1 2. Okay, this is one of the very interesting peculiar product is formed in this case. So this is all about some little bit deep culture about the Reimer-Tiemann reaction. That's all.